Okay, question 4H1 for second edition of Statistical Rethinking. So here's the question here. So from the, I think that they pronounce like Kong or something, I'm sorry, but this census data from the chapter, it wants us to find expected heights and 89% credibility intervals for particular weights, and the weights are listed here in the table. So let's just give a little bit of background here. So the first thing to know is that you need to make sure that you have the Rethinking package installed and uploaded with the commands here and here. And the model that we're using is presented in the chapter. It's a model M43, in which we have a bunch of weights for individuals over the age of 18, and we're predicting the height based on that weight. Now, what's a little bit interesting about this question is that we are now going to be asked to find the expected height and the credibility interval for values of weight that may not be represented in the data, right? And so with these methods, with regression methods basically, we're able to say, okay, well, we expect the value, the expected height to be such and such based on certain predictors, okay? So let's get into this. So first we need to run the model. So this is just verbatim from the chapter, okay, and also from a previous problem in this problem set. But we have our data, it's called HAL1. We select just individuals over the age of 18, and we also need this variable, the x bar, which is just the mean weight of individuals, and there's reasons for that we addressed in earlier questions. Okay. Something else that's going to be useful is if we take the weights that we want to find the expected heights for and put them into a vector. So these values are just the values that are presented in the table. Okay. So we want to, again, find the expected height and the 95% credibility intervals for these different weights. And so the way that we're going to do this is we're going to sample from the posterior distribution that we found here in our model. So I've already ran this, okay, and here's the model, and we've got a posterior distribution. And so we're going to use samples from that posterior distribution to calculate the expected height and the credibility intervals, right? So now notice that in the model, we only have parameters for alpha, beta, sigma. In other words, even though there is a mu here and a height here, but that's the data, but even though we've defined something called mu, which is not in the data, mu is again being constructed by things that either we're estimating or the data. It's being estimated by A and B, alpha, beta, as well as weight and x bar, okay? So in order to find the expected value for height, we're going to have to combine the things that we have, weight and x bar, as well as A and B, the posteriors for A and B, and then use those to recreate appropriate mu values, okay? So in order to do this, we're going to extract samples from the posterior distribution. That's what this command does, which is part of the Rethinking package, okay? And we're calling it post for posterior, okay? And then we're going to write a function and use that function, but we're going to write a function that I'm calling estimate height, okay? And if you're unfamiliar with how to write functions, I guess kind of pay attention to the structure here. But I'm going to create a function, and I'm going to input. So I'll be able to apply this function wherever, and we're actually going to apply it down here. And the thing that the function needs in order to function, the function that we're calling estimate height, is it needs a particular weight, okay? And so first, it's going to generate samples, okay? And in order to do that, I'm going to generate normally distributed values, heights, and how many of them? Well, I'm going to generate one sample for every sample in the posterior distribution, okay? And so I've said length, and then A. So these are the samples that we found in posterior, in post. So I'm going to generate that many samples. Okay. And what do I want the mean of this normal distribution to be? Well, I want it to mimic my model here. A plus B times height minus X bar. Okay. So I'm just going to recreate that. So it's the mean is A as found in the posterior distribution. Okay. And then B times weight time minus X bar. All right. And if you're not familiar with this, so the A, so when I have post $, that means that go to this object and look for this piece of it. Okay, so I'm looking for the A that's defined in post. Okay, and similarly for B. Okay. Now that's going to define a mean value for a particular height, or I'm sorry, for a particular weight, the weight that we're defining in the function. I'm going to pass this to the function. Okay, and then and it's going to do that for every sample in posterior. But then if I want just one value for expected height, I'm going to take the mean of all of these samples. Okay. And if I want the credibility interval, the 89% credibility interval, I want HPDI or PI of the height samples that I've generated for the particular A and B values, etc., and I want the 89% credibility interval. And then I'm asking the function to return this value and that value. Okay? So I'm going to pass it a weight, and it's going to spit out a mean height and a mean in a credibility interval. Okay? And so then I actually want to apply that to all weights. Okay, and remember weights we've defined earlier here, which is just the weights that are given to us in the problem. So I'm going to apply with this sapply function. So I'm going to apply this function, the function we just defined, to each weight. Okay, and it's going to give me, well, it's going to give me a readout here. Okay, and so the top row here looks like the expected values. Okay, so that's the expected height for the first weight, the expected height of the second weight, and so on. And then it's given me the 5 and 94% credibility intervals here. I'm not sure if that's right, but anyway, it's given me the upper and lower credibility intervals here. I can't, but okay. So now we have, just to make it look a little bit better, I'm going to take this input here, okay, and I'm going to transpose it. So in other words, whereas expected heights are a row here, I'm going to transpose it to make it a column, and similarly for the upper and lower credibility intervals, okay. And so the way that I do that is I'm going to C-bind, I'm going to column bind the weights, which again is this vector here, so that's going to be one column. And then I'm going to take this whole table here and transpose it with this T command here, okay. And when I spit it out, so this is our final table, okay. So we have the weights as were given to us, the mean heights, and the credibility intervals. Okay.